Good morning, everybody. We should begin. I just have two announcements to make. Well, first I would introduce myself. My name is Annie Cott. I'm a member of the Executive Committee of the French Economic Association, and I have the great pleasure to chair this Jean-Jacques Laffont keynote this morning. Two announcements before we begin. First, we will not leave the room before 11 o'clock. We will go on, so that's just for you to go and run and get some coffee if you need it before that. We will listen to Abhijit, then award the prizes of the French Economic Association, then have the General Assembly of the Association, and only then you are allowed to leave the room. Before that, totally forbidden. One word before introducing our keynote. There are 4 prizes announced during this Congress. Yesterday, Jeanne Como, who is here, no, she's sleeping after partying all night, received the Association Française de Sciences Économiques and Banque de France prize for her dissertation. The Association Française de Sciences Économiques prizes for PhDs will be announced just after this conference. And the best article, the Edmond Malinvaud Prize for the best article, will be announced tomorrow. One of these prizes is missing. The prizes for the best books in economics will be awarded at the French Parliament, the Assemblée Nationale, next week on May 14th from 9 to 12 with a round table on fiscality and democracy. And we would ask you to join us at the Assemblée Nationale. Pascal Lemairer is organizing everything. Agnès will be speaking at the round table, so I suppose these are the two details which should attract all of you. May 24, Assemblée Nationale. I think you have to register for security reasons, but please do join us. And I have the pleasure to introduce Abhijit Banerjee. Abhijit studied economics at the University of Calcutta, at the Nehru University of Delhi, and at Harvard, where he wrote a PhD entitled Essays in Information Economics. After some time spent at Princeton and Harvard, he became professor of economics at the Massachusetts Institute of Technology at the MIT. In 2003, he founded the Abdul Latif Jamal Poverty Action Lab, the JPAL, together with Esther Duflo and Sendil Moulay Nathan. Abhijit Banerjee has been president of the Bureau for the Research in the Economic Analysis and Development, has been a research associate of the NBER, a fellow of the Kiel Institute, of the American Academy of Arts and Sciences, and of the Econometric Society. He has been a Guggenheim Fellow, an Alfred P. Sloan Fellow, and served as on the United Nations, not the United States, the United Nations Secretary General's high-level panel on the post-2015 development agenda. He authors a large number of articles and books, Volatility and Growth, together with Philippe Aguillon, who was there yesterday and should be there today, partying also. This was in 2005. Understanding Poverty, edited with Roland Benabou and Dilip Mukherjee in 2006. Making Ed Work in 2007. Poor Economics, together with Esther Duflo in 2011, and last year also together with Esther Duflo, the 2 volumes of the very beautiful Handbook of Field Experiment. It is both an intellectual pleasure and an academic honor for our society to have Abhijit as a Jean-Jacques Laffont keynote speaker this morning. Please join me in welcoming him to our Congress.
Thank you. Thank you for that welcome. Thank you for inviting me to give this lecture. It's an honor and a pleasure, and a particular pleasure because we had the indulgence of being at PSC for the last academic year and enjoyed it thoroughly. So this has been a good capstone on that very pleasurable year. Thank you. So I wanted to talk to you about network economics. It's sort of like, in a sense, it's at some level it's bread and butter. If you think about it, everything's mediated through networks. We economists sometimes pretend that there's a market everywhere, but it's an implausible pretense at best. So I'm not going to insist too much on this fact. It's obvious. Now, how does one incorporate networks into economics? Now, this might sound presumptuous because, there is an enormous literature on this subject. However, I think there is a number of important choices we make when we decide how to incorporate it. And my entire talk will be, in a sense, what have we learned about how to make those choices? And the key dimensions I'm going to emphasize are economic versus other motivations, random versus designed networks, and sophisticated versus naive decision makers. Each of this, I think, poses a problem for the field and an interesting challenge as well. So this is what I think makes life in network economics interesting and potentially makes it an exciting area for much more research. So it's both, I think, something where I think there is something now to say. There's some empirical work which I think answers some of these questions, and I think there is a lot more not said and that needs to be said. So let me start with the first one. Now, what motivates network actors? This is sort of a big question. In a sense, it's the one of the starting points of economics. And why networks? Everywhere, this is the same question. However, I think in some ways networks makes a lot of what is difficult about answering that question salient, because it brings up the issues that have to do with all the things we do kind of in the moment as a part of being us. So we talk, we chat, we smile, we hug, we give gifts, we do favors. Or many of those things, it's hard to imagine that they're all directed towards some very clear goal. That I do everything because I want to get something from somebody. So it poses the question, once you think of the world of networks, it poses the question of what is it, how do we model human beings very starkly? Because it's sort of, it's a context where as you know from introspection, it's implausible that all of your actions are guided by some very clear economic motive. It seems just not intuitive. So in that sense, I feel that it opens up the question of what is it that we are doing when we are doing this, since it's so much a part of who we are and what makes us human. Now the models go from one extreme to the other, not surprisingly, partly because of that. There are models where there is essentially no explicit decision making. You have infection models is the most obvious. If somebody else is doing it, I see it with some probability, I do it. There is no decision. The probability is exogenously given, and therefore it is nothing to do. There's no decision whatsoever in that, and that's one way to resolve this tension, is to so completely give up on all decision making. The other extreme also exists. For example, in my field of development economics, there is an enormous literature on collective insurance and how exactly people who help each other are actually thinking complicated thoughts about that. So there's a large literature which kind of models exactly what would happen if I could walk away, and what would stop me from walking away from helping somebody, when would I choose to help somebody and not help somebody, etc. So there is a large literature, and there is obviously some echoes of that in life you see as well. It's not always that everybody helps everybody, so clearly there are limits to that. So it's clear that there is some interesting thinking on that side as well. So I'm going to tell you about a few experiments we did, which maybe help us think a little bit about this question. So here's an experiment we did. In 2016, on November 8th, turns out it's the day that Mr. Trump got elected. So this is not one of many disasters that happened on that day. India demonetized. It removed all 86% of all currency was removed all at once. It was no longer currency. This is all the 1,000 rupee and 500 rupee bills were suddenly not currency. People were given 52 days to deposit the bills in their bank account, and if you deposit the bank account, you get full credit for it. But you had to go through that process, and it turned out that the banks had forgot to print the bills to replace them, so there was enormous chaos. There were 54 rule changes in 52 days. Every day there'll be a new rule on this is how much money you can take out of the bank, or this is how much money you can put in the bank, or this is what under what conditions you can take out more money than that, etc., etc. We made a list of every day there'll be a new rule. There was huge amount of confusion. Our experiment was basically giving people information about what the rules are. Okay, this is actually the rules, and we did it at the last 10 days, by which time the rules were more or less stable. There were a few changes, but not many. So we kind of waited till the end. There was this risk involved because maybe your experiment never gets finished, but at least we picked that time. We distributed information on the correct rules randomly across 225 villages. There are two dimensions of variation in the intervention. One is that either everybody in the village was informed, or only 5 people were informed. Okay. 50 or 5, okay? And the other was common knowledge. Did I tell everybody that everybody was informed? Did I tell everybody that 5 people were involved? Did I tell nothing? Okay? So it's 2 dimensions of variation. So we could have full info. Everybody, which I'm going to call. So I'm going to call that broadcast. And broadcast could be combined with common knowledge. Broadcast could be combined with no common knowledge. The other I'm going to call seeding, giving to a few seeds, and that again could be combined with full common knowledge or no common knowledge. Okay, those are the options. And now I'm going to tell you how did we measure outcomes. Well, we have 3 dimensions. One is just how do people behave. Was there more discussion of demonetization in the villages where we gave the information? Second, were people actually more informed? And the third, were people willing to take a 500 rupee bill to deposit in the bank? We gave them the choice of that or 200 rupees in what was still valid currency, but to be given to you in 3 days. So that people just didn't grab the 200 rupees because it was now. So the other one, they had to go to the bank to exchange. It was still legal to do it. Everybody had a bank account, etc. So there was, we gave them a choice between you either go to take 500 or 200. So the question is, if people are fully informed of the rules, they should have taken the 500. But as you'll see, most didn't. Now, I'm going to show you the results in this form. These are 4 bars. Seed, no common knowledge. Seed, common knowledge. Broadcast, no common knowledge. And broadcast, common knowledge are the 4 bars. This is the volume of conversations. This is how, how many people were talking about demonetization. And you can see a pattern that will show up. I won't show you the knowledge one just to save time, but it's in all the three graphs. The same pattern shows up, which is that seed, common knowledge, and broadcast, no common knowledge do much better than the other 2. And I'll explain that, of course, but in a minute. So here's the outcome of most economic interest. Most people didn't take. You can see that really 5% took took the 500 rupee bill. It was really, this is throwing money away, a lot of money. This is more than a day's wages. They're throwing away much more than a day's wages. So it's a lot of money. They're throwing it away. If you give them the seed common knowledge or broadcast no common knowledge gives you about 12-15%, and then broadcast common knowledge gives you again less, back down towards 5. So that's the set of facts. Okay. So let me tell you why these facts make sense. So, if everyone knows, and everyone knows that you know, then if I don't understand what those, I got some information, but I didn't understand it, I'm going to be shy to ask, because I look like an idiot. Weren't you told? Didn't you read it in the pamphlet that these people gave you? So you feel like an idiot, so you don't open your mouth, you don't ask questions. On the other side, if you are the only you know that you were not given the pamphlet, and everybody knows that, it's common knowledge that you didn't get it, then of course it's easy to ask, because I know Agnes got the information. I'm going to go to Agnes and ask her. There's no shame in asking, because everybody knows that I don't know. Okay, so seed common knowledge works. Broadcast common knowledge doesn't work. Broadcast no common knowledge works very well, because when I broadcast, everybody gets the information, and since it's not common knowledge, they can go and ask people. If I don't understand, I ask people. People are not sure whether I didn't get the information, or if I got the information I didn't understand. There's enough uncertainty, so I can hide behind that. So essentially, you find that in other words, people are clearly. It's not mechanical. There is a decision being made, but the decision is not the income maximizing decision at all. You could think of this as being signaling. It's one possible interpretation, but it could just be embarrassment. I don't have a particular reason to hide the fact that I was confused, but I just feel, come on, I feel like an idiot. So I have no idea. So I can't tell you which is going on, but it's clear that what is important is that there is strategic motivation, but the strategic motivation may not be the one that's the most obvious one. Second, from the policy point of view, what this says, which is I think is that you should, if you want to plant information, the most effective way to do it is to do seed common knowledge, meaning because broadcast no common knowledge is actually hard to do. We did it, but think of it, you're telling it to everybody, but nobody's finding out that you're telling it to everybody. That's a lot of work. What's much easier is to just give it to a few people and tell everybody. That works very well. So that's actually a very useful fact, and one that will become relevant in a minute as well. But then the other side of this is that, again, as I said, some people are shy. They don't want to ask questions. Other people are not shy. And I'll see you say, these are 2 field experiments on how to spread information. So the question is, now we go back to the thought we already planted, which is that seeding is effective. So now let's start from that point. So if seeding is effective, who are the best seeds in the community? Okay, how do I know who's the best place to see? Who's the best person to inform? Okay. Now, network theory. So one way to think about this is to use network theory. Network theory, if you use, for example, an infection model, gives you a very specific prediction, which is you want to, in an infection model, basically what happens? I talk to somebody with some probability, she talks to somebody with some probability, etc. There's some possibly random probability that we use to communicate, and that's how information spreads. So information spreads because everybody kind of mechanically has some fixed chance of speaking, and that makes information go. Okay, so that's in that world, it makes sense to think of it's very, you can sort of see the theory where theorems you can prove. The theorems basically say what's going to be a good measure of who is a good place to give information to? Well, that's going to be somebody who's very well connected, meaning somebody who's well connected to a lot of people, and whose friends are connected to a lot of people, and whose friends' friends are connected to a lot of people. And that's the idea of eigenvector centrality. That's the idea of eigenvector centrality. That's the Google rank, essentially. So if you happen to be well connected to well connected people, etc., ad infinitum, then your eigenvector centrality is high. That's one way to theorize the idea that who are going to be the people who going to be good seeds. There's some variant on that. We have a paper on something that's, if you don't want to wait till infinity, then you might use a different measure, but it really is not important. Now, we do know, and we have another paper where we show that if you happen to seed kind of accidentally happen to seed more central people, then the information does flow further. So in very practical context. So we have some evidence of that. That doesn't answer the question, who's the best person to seed? I'm asking a different question. It's true that more central is better, but is there something even better you can think of? Also, finding central people is a pain. Why? Because you have to know the network. How do you know the network? Well, you ask everybody questions about all their friends, etc. It takes a lot of time. I've done it a lot, and I can assure you it's not fun. It's a lot of work. So maybe we just go and ask somebody in the village. Do you know who the village gossip is? Okay. Who's the one? So can we just use gossips instead of central people? Just forget about all this complicated stuff about networks and centrality and inverting a matrix and all that. We just go and ask the villagers, do you know who the gossip is? And we're going to frame that question in two different ways. We're going to say, who are the people, if you wanted to spread information about a fair, who would you inform? If you had to spread information about financial product, who would you inform? These were two different ways of asking this same question, but that's what we did. This is randomized across 213 villages. Well, in every village we did the same exercise, which is went to 15 people and asked them, tell us who the gossips are. And there were two ways of asking it, as I said, about fairs or financial products. Remarkable agreement. First fact that I didn't know is remarkable agreement. Only 4% of the households are named. So, everybody agrees. If they name somebody, they name the same people. That's number one. It's quite striking. Second, once you name 9 times. So 9 different, out of 15 people, 9 people name you. So you get a fair number of, most people know who the gossip is and they name the same people. Okay, so that's second fact of. These are not just their friends, so that should be obvious, since different people chosen at random are naming the same people. They can't all be the friends of the same people. And in fact, they're not. They're more likely to be friends of friends than friends, and even further down the chain. Then we randomized seeds in three possible ways. You can give it to random people, the information. You can give people information to gossips, or you can give it to the village elders. We asked a question about who are the important people, etc. And the information was about a raffle. If you had a number to call, if you call that number, you were entered in a raffle, a lottery, and you get a free prize. Okay, so there was enough interest in it, as you'll see. But here's the basic fact. The basic fact is that elders and gossips do about equally well, not on average. They don't really. Elders and random do equally well, and gossips do much better. Gossips are just overwhelmingly better. Essentially, this graph is harder to interpret, but this is the reduced form, because random and elders include gossips. So some of those people are. So therefore, what you really want to do is the IV, the instrumental variable estimate, to separate them. When you do that, you find that there is basically giving gossip the information gets you to 3 times as many people. So gossips are just, they're just much, much more effective. Okay, so that's first fact. Now, problem with this particular example is that this is about some raffle where a cell phone was being given away. Who cares? As a social policy, maybe the cell phone company cares, but as social policy, it's irrelevant. So, is there something else we can do? Can we make something more important happen? So the next thing we did was we looked at spreading information about immunization camps. Same methodology, but different question, which is, can I get people to immunize their children? There are camps in their village where you can go and get your children immunized. The camps happen on a particular day. Can I get somebody in the village to, tell everybody, well, you should go and get your children immunized? Okay. This time, instead of taking elders, since elders didn't do particularly well, we took trusted people. We asked, we thought maybe it's going to be much more important to be trusted, because immunization, after all, is a much more personal, much more delicate decision. So maybe it's important that the person I inform is trusted. The outcome was the number of children immunized. So basically, you can look at the table. This is all compared to random. Gossip does best. Trusted does somewhat better, and trusted gossip does equally well as trusted, but gossip does best. At this point, gossip is significantly better than random. It's not significantly better than trusted, but this is just based on the first couple of months of data. We're going to have data for 2 years. I think our guess is that it's going to do much better. So gossips rule. Increase the number of children immunized by 20%. So that's a policy relevant magnitude. It's something you may actually think matters. Okay. Question. I told you that more central people are better as well. I didn't say anything about centrality so far. Now, our gossips are more central, but because we have this set of villages where we seeded random people, we can separate hitting a gossip and hitting a central person. In those villages, who's chosen is random. Therefore, I can compare the people who chose the gossips in those villages who got chosen with the when in those villages instead you chose one of the central people. And gossips are much better than central people. Gossips are gossips. They are good at this job. They love doing it, and in a sense, all this sort of gossips gossips are often central. That's natural. They talk to a lot of people, but they are much better than their centrality predicts. So, implication for network theory. By focusing on network structure and network-based communication, there's a danger we forget the human element. Some people are shy, and being in an information-rich environment might actually hurt them. Others love to talk, and they'll dominate all conversations, irrespective of their centrality, and they don't need to be paid for giving away the information. They love giving away information, and that's I think the key sort of message you want to take away is that I think we have to think of a model that incorporates a lot of things we do, which we do it because we like to do it and not because we are expecting to get paid for them. And I think that I think is from this piece the takeaway. How many minutes more do I have?
How long? You said 35 minutes?
Yeah.
10.
10. Quarter of an hour. Perfect. Okay. That's nice. Second question, random versus designed networks. Long tradition on both sides. In computer science and biology and sociology, random graphs and lattice networks are the sort of basic, you think of everything as happening mostly by chance. People happen to be next to each other, they get connected. People happen to be in a room and somebody meets somebody. Those are random graphs, and that's the basic. There are different models of random graphs, etc. But that's the basic way of modeling networks. Economists have often gone completely the other way. So, for example, there's a nice paper by Rosenzweig and Stark on strategic marriage alliances in India, where they show that people who, when they marry their daughters, they pick people from families whose rainfall experience is very different from theirs. So they want to be uncorrelated with the people they marry their children to, so that they get insurance. Now, whether I believe exactly that or not, it's an interesting thought. And there are papers along that line, very, very much a design paper, where the network is designed. I make friends with people for a very specific reason, which is that they are beneficial to me, and I choose those people. Then there is some nice theory. I don't know if Francis is here. So there's Bloch and Jackson-Walensky. Quite a long time ago, there was nice theory showing that typically designing a network is going to require a social planner. That is, if bilateral decisions are made where I decide to make a friend with somebody even for economic motives, I won't internalize the fact that when I make a friend with somebody, I benefit people who are my friends or hurt people who make my friends. So I don't take those into account, and therefore the design of the network is typically going to be suboptimal. Even if people are kind of economically motivated, they're not going to come to an optimal network. Okay, so that's theory to keep in mind. Some evidence from impact of microfinance. This is data from 75 villages, all of which were supposed to get microfinance. The global financial crisis intervened, so 43 eventually did. We have panel data collected just before microfinance arrived in the village, and 5 to 6 years later. How do the networks change? So 2007 and 2012. How do the networks change? Well, all networks shrink. People lose connections on average, but microfinance villages lose substantially more connections. So people, when you get, so let me tell what I say about microfinance is. Microfinance is a financial product available to poor people. So these come to the village, they're offering microfinance in the village, and people in the village are taking up microfinance. When you look at what that does, this is just difference in difference. You see a reduction in the networks in both places, but in particular, the places where microfinance entered, the network is reduced more. People are less likely to name people as friends. The number of friends goes down by more. And not a insignificant amount is a 12 percentage points extra reduction in these villages. So quite a big reduction in networks. Is this causal? Well, there's some, we think it's causal, but I don't want to spend time explaining why. I mean, it's not experimental. So now, this is not particularly surprising. You might say, well, one reason I make friends is to get money from loans from people. Therefore, now that I don't need to do that, I don't actually need those friends, so I have abundant some number of friends. That doesn't surprise. What may be more surprising is what we can do, because we know the model of how microfinance is given out. We can look at people who are eligible and people who are not. So people who who are much more likely to get microfinance, and people who are not in all the villages. We can predict, even in the villages we didn't get microfinance, we can say this kind of person would have got microfinance, this person wouldn't have got microfinance. So think of them as high types and low types. People who would have got it and people who wouldn't have got it. It's a very good predictor. If our predictor says that the people who are high types are 10 times more likely to get 10 times as much loans from microfinance. So very good predictor. So we have two groups, people who are likely to get microfinance and unlikely to get microfinance. And what is striking is that the people who are unlikely to get microfinance lose borrowing from friends more than the people who are likely to get microfinance. So it's the people who are unaffected who seem more affected than the people who are affected. Total borrowing goes down for these people. For the people who don't get access to this financial opportunity, their total borrowing goes down, their total number of friends goes down, so does it for everybody else. So it's the people you think for whose friends would be very useful, in fact, because they are not getting access to this product, lose more friends than the others. And that's something to keep in mind. The smallest change is friendships between the high types. That doesn't change as much. What changes a lot more is low types versus low types, or low types versus high types. And that's the surprising fact. Okay, so now, why? So this is not consistent with random link formation. Random link formation, of course, should not be correlated with your type. So it cannot be that this is happening through random link formation. That it cannot happen with perfect design, because the L's need credit. They are the ones who are not getting it. Why would they not be forming links? The L's, the ones who need credit, are not forming enough links, so it's not consistent with perfect design, not consistent with any model of link-by-link decision making. Because if I am choosing to make a link based on the payoffs, I should want to make links when my needs are higher. And the fact that the people whose needs are higher are making less links so we have a bunch of models in the paper showing that on any model of link-by-link decision making, you can't get this. Not consistent with link-by-link decision making with support. This is a nice idea. The idea is from a paper by Matt Jackson, is that suppose I make a link, and it's true that for that link to be viable, I need common friends. So it's not just enough for me to call this person a friend, because I don't see him enough. But if we had a common friend, we would meet a lot more. And so this is the idea of support. So relationships with our triangles are more stable than relationships that are just bilateral. Now, that creates a spillover. It creates a spillover between suppose the H's don't want to make friends with anybody anymore. They want to stay home and watch TV because they bought a TV with their new loan. Then the L's are in trouble, because the L's were relying on their H friends to bring them together with the other L's, and so they don't meet the L's because everybody was connected through the H's. Okay? So that's plausible, except that would imply that the triangles which are LLL, only L triangles, will be the ones which are most stable. We see the opposite. The LLL triangles vanish the most. So that can't also be the explanation. So what could be the explanation? The explanation has to be that people are essentially doing what we call undirected search. So you go to the tea shop, you hang out, you make friends. So your decision is not to make friends with X. It's not link by link. You go to a place where you can make friends, and then you kind of randomly meet people. So people are moving out of the tea shop. That's the model that fits the data best. So in other words, the reason why, in other words, these are not unmotivated links. I'm going to the tea shop to meet people, but basically, if once I get there, I don't get to choose my partner. Otherwise, the L's would all go to the tea shop and meet each other. What's going on is that the L's say, well, now the tea shop is empty all the time because the H's have stopped coming. Therefore, we don't go to the tea shop because there's no one fun to meet. So in other words, there is very little design in this world. So in other words, this world is one where, yes, people have motivated, but the design is very weak. There's not much design. It's all kind of random matching. In the end, we take a choice. We go to the tea shop or not. Once we make the choice, it's kind of like random matching. That's a world that fits the data. In other words, when we retreat to Facebook, our friends have no choice either. There is negative externalities in this world. So if we exclude ourselves from hanging out with our friends, then their networks also will collapse. Last example, how much sophistication? Big question again, but very salient in the network context. You can, interpreting network communication is hard. This example shows you why. I get the same message through two of my friends, but they were both friends with third person. Now, if I have to choose my optimal interpretation of the information I get, if I have to be Bayesian, I have to have a priors over all the pathways through which the information could have come to me. I have to think about, X could have talked to Y, talked to Z, talked to P, talked to L, and then it came to me, or it could have come to X through Z through Y, and then to P, and then back to X, and then to P and back to me. All those pathways I have to think about. It gets combinatorially complex. It's NP hard, this problem of figuring out what pathways the information could come to you from is just too hard to know. So as a result, what people have been arguing is that you have to use some rule of thumb. You cannot process information by sort of just thinking about all the possibilities. There is a nice experiment that we didn't do, so I can say nice, which tries to separate them. The idea of the experiment is the following, and I just want to take 2 minutes. 2 minutes to explain. One, I actually need two to once show you this. So this experiment is very neat. So think of the blue as the people who have been informed. People that have been informed are the blue. The next period, the whites observe the blue and they have to decide. Now, if you're a kind of rule of thumb decider, you'll say, I see one white and one blue, why should I change my mind? So these are people I'm going to call, I didn't want to define de Groot, but de Groot is a particular model of that. And you can see that essentially after one period, if you're Bayesian or you're de Groot, you don't change your mind. After 2 periods, however, you see very different outcomes. Why? Because the Bayesian thinks the following thought. He sees the blue, the two whites see that blue and says, that blue, he didn't change his decision. If he saw one more white, he would have 3 whites and one blue. So he should change his decision. He didn't change his decision, so he must have seen another blue. And therefore, there must be 3 blues there. Okay? And as a result, he should change his decision. So that's what makes a Bayesian. Now, if you look at, there's a nice experiment where there's a race, where they run a race between de Groot, de Groot is this simple rule of thumb, and Bayesian, and in that experiment, de Groot wins hands down. The rule of thumb wins hands down. You have people play these games, nobody can figure out what I just explained. And so everybody plays it kind of like blindly. The blues or the whites on the left don't move. Okay? And it's a huge, the standards are very precise, and you can reject that people are Bayesian. Now, on the other hand, these rules of thumb are also very weak models. They tend to have all kinds of properties we don't like, including the fact that people don't seem to be at all aware of uncertainty in these models. Bayesians, after all, think of the whole distribution. In the rule of thumb models, I do either X or Y, depending on which one I see. I don't assign any uncertainty there. And we see lots of evidence of people being uncertain. We have a paper where we ask people, who's richer, X or Y? Well, first, they are reasonably good at ranking people who are near them, bad at people who are ranking far from them. But more importantly, when they're bad, they say, no, I don't know. So in other words, people are very aware of uncertainty. They understand that they don't understand. And that just not captured. So in some sense, we need more sophisticated ways of thinking, which are not Bayesian, but somehow still able, so not dealing with the infinite complexity of this world, but still, I think, much, has a degree of sophistication that we don't have. So to summarize, network economics has been reasonably open to the idea that the kind of optimization economics always want to is not all necessarily a useful guide to how people actually behave. People are not supercomputers out to make money. That's sort of our first order modeling. So I think that's now, that leads us often to the opposite extreme of people making random decisions and mechanical behaviors. There is lots of evidence that people pursue motives, not necessarily economically obvious motives. Gossips like to talk, but they pursue motives. And so in some sense, we can't just have mechanical decision making either. And just to summarize, people are human after all. Thank you.